In this video, we're going to talk about how to find vertical and horizontal asymptotes for a rational function. Our rational function is f of x equals negative 3x squared plus 9x minus 6, all divided by 2x squared plus 1. Now, when we want to find an asymptote, what that really means is a vertical asymptote is like a dotted line that your function, kind of approaches, but it never touches. A horizontal asymptote is very much the same. It's just that what your function, the graph of your function is working toward as you move toward positive or negative infinity in the x direction. And so the idea is it's what's happening or what tends to happen as you move toward an infinite value. And so looking at the horizontal asymptote first, we have three different cases that you need to be aware of over here in the green box. And you would want to have these memorized, of course. These wouldn't be written on a test or something. And the three cases are either you have the same degree on top and bottom, in other words, in the numerator or denominator. And if that's the case, then your horizontal asymptote is going to be y equals the ratio of the leading coefficients. The second case is the numerator has a higher degree. If that's the case, then there is not going to be a horizontal asymptote. And the third and final case is the denominator or the bottom has a higher degree, at which case y equals 0 is going to be the equation of your horizontal asymptote. So looking at our example, the degree, of course, is just your highest exponent. The highest exponent on top is 2. The highest exponent on bottom is also 2. So we're going to have a case where we have the same degree on top and bottom. And so what that means is the equation of our horizontal asymptote is going to be y equals the ratio of the leading coefficients. Well, the leading coefficient on top is a negative 3. The leading coefficient on bottom or in the denominator is a 2. And so the equation of our horizontal asymptote is y equals negative 3 over 2, or negative 1.5. And so that's the answer for our horizontal asymptote. You're only ever going to have one of those in a rational function like the one you see here, so your job is done as far as the horizontal asymptote is concerned. Now for the vertical asymptote, what you want to do is you always want to factor as much as you can on top and bottom, and then you want to cross off any common factors on top and bottom. Because when you do that, if you cross something out in the denominator, what you're doing is you're taking away a hole in the graph. So the ultimate goal is we're going to set the denominator equal to 0 and solve for all those x values. But if a factor cancels out, then that means it's just a hole and not a vertical asymptote. So looking at our particular problem, let's go ahead and factor. So in the numerator, we can factor a negative 3 out of all of our terms, leaving us with x squared minus 3x plus 2. Now the denominator we can't factor. 2x squared plus 1 does not factor in any kind of nice clean way. So even though the top can be factored further into negative 3 multiplied by x minus 2 multiplied by x minus 1, it really doesn't do us any good because we can't factor the denominator. And so really that doesn't get us anywhere because nothing is obviously going to cancel out. So now that we've gone through that precautionary step, the next thing to do is to set the denominator equal to 0. Again, we're going to kind of run out of luck here because if we set 2x squared plus 1 equal to 0, then we're going to get 2x squared equals negative 1, x squared equals negative 1 over 2, and then when you take the square root of both sides, we're going to get x equals plus or minus the square root of a negative number, which that's no good. That's not a real number. So in this case, we don't have any vertical asymptotes since we didn't end up with a real number. So what you could just say in this case is that there are none. And that's your final answer.